And so going to the outline for the notes today, we're just going to review. Tests and statistics will be due by,
Oh, wait, so is the test going to be available today?
after
Oh,
class
okay.
today. And I'm rethinking that by midnight on the 18th
hmm
is Wednesday. You know what? Would it hurt anybody's feelings if I gave you until the 19th, which is Thursday, in which to finish it?
No.
Good.
And that way, if anybody runs into any Blackboard problems, we can deal with them on the 18th. All right.
Okay.
Bunch of homeworks are due by the end of the day today. Hopefully you've been keeping up with them as we go along. I'd like to
Mhm.
go over that review sheet, that practice test that I had placed in Blackboard. I'd also like to walk you folks through the next project that's in Blackboard. Before we do either of those, does anybody want to look at any homework questions?
I think it's the third one, number 1.
The last assignment that's due?
Number 1. I don't know what I'm doing there.
In a certain study of women's heights
Yes.
are found to be approximately normally distributed with a mean of 64 inches and a standard deviation of 2.5 inches. What would be the Z-score for a woman who is 5 feet 6 inches tall? Well, in order to do this, what you have to be aware of is the fact that 5 feet is 60 inches. So 5 feet 6 inches is 66 inches. So we're looking for a Z-score for 66 inches, which is the data value 66 minus the mean, which is 64, divided by the standard deviation, which is 2.5. So that gives me 2 over 2.5. And they want it to 1 decimal place. So I'll take my calculator and I'll go clear 2 divided by 2.5 gives me 0.8. Great. And then the second part, taller than 1% of women. The percent of women that she's taller than is her percentile. And so I'm going to click on this icon here, which is the table. And we've got a score of 0.08. So looking for 0.08, that gives me 78.81. Do you see where I am?
Yes.
So she is taller than 78.81% of women. Better?
Okay, so you multiply 5 feet, that's 5 times 12 give us 60, right?
Right.
Then what about this 6?
I added it. 60
added it.
66.
Okay.
All right.
Okay, like mine is asking 5 feet 10 inches. That's 60 plus 10 inches.
Yep, it's 70 inches.
Oh, okay. I think that's what I was doing wrong.
Okay.
All right. Thank you.
Anybody want to look at any other homeworks? Not hearing. Let's go through real quick, and in content, let's look at the folder for projects. In the folder for projects, there's a Dropbox down below where you're going to submit the picture of your work, but I'm going to click on the assignment itself. and it's coming up down below as a Word document. I'm going to open it. So it's due on Monday. Oh, so you've got a week to do it. You're going to go to either the Buffalo Bills, Sabres, or Bison's web page. Then as you look through the web page, you should be able to find a place that has statistics. I said player statistics. It could be team statistics. As I was looking at the Buffalo Bills, there was, when I first clicked on players, it gave me like all of their ages. You could use that. It gave me all of their heights. It gave me all of their weights, things like that. Or you could go by position and, whatever stats they have there. I also, Sabres, they have it broken down by season, by, points, and I don't know, all those silly hockey stats that people pay attention to. And in the same way, if you go to the Bison's webpage, I try to include the Buffalo Buttes, but when I went to the Buffalo Buttes, the statistics that they had, it was all zeroed out, and they didn't have a way of for this season, and they didn't have a way of looking at back seasons. All of the other teams, it seems like there was a place for back seasons. If you're not a Buffalo sports fan, if you want to get statistics from another team, that's fine. If you're not a sports fan at all, I guess you could use other data and not sports team statistics. I had just thought that usually I kind of always used to leave it wide open, and people were kind of like, I don't know what I want to do. But, just we're looking for numeric data for, I said you need to just pick it for 10 of the players. Then write down, tell me what the data is, tell me where you got it from, write down the data. Doing that much is 4 points. Then represent the data graphically, making both a histogram and a stem and leaf diagram. Discuss what you notice in your graphs. That's worth 6 points. Then find the measures of central tendency, mean, median, mode, and mid-range, and compare them. Tell me what you think is the best description of your data. That's worth 6 points. Then find the standard deviation of the data. Discuss what it tells you about the data. That's worth 4 points. So the math of it is 20 points. And then turn it all in and write a real brief report summarizing your answers to the questions. The summary report is worth 5 points. So it's a 25-point project like all the others.
Mm-hmm.
I think a week should be sufficient. If it becomes problematic for anybody, let me know. If you have a hard time accessing the data, let me know. I mean, I could have just given everybody the same data to use, but I had thought it might be more interesting to look at data that interests you. So again, if you're not a sports fan and you don't want to use sports data, let me know what data you want to use, and that works too. I guess if anybody wanted to do anything like data with respect to the election, I guess that would be acceptable. Whatever floats your boat, folks. Okay, I'm just looking for you to do a statistical analysis of a data set, and I'm suggesting the sports teams because I know that's easily accessible. But if you want to do a deep dive for some other data that interests you more, fine. I'm looking for histogram, stem and leaf diagram, mean, median, mode, mid-range, standard deviation, and what the hell does all that tell me? Okay.
Okay. For the central tendency, how would I know which one best describes the data?
You're going to just look at the numbers, and it's an opinion. You're going to say, which of those numbers do you think is, a best description? Like,
Okay.
I think when we looked at something like ages of people in class, when we included me, we decided the mean wasn't real good because the old ladies, the data. When we looked at, different descriptors work better for different things. So you're going to look at it and say which you think is the best description of the average of the middle of the data set that you're working with. It's your call. You can decide how you make that decision. You just got to do a real good job explaining to me why you reached your decision. Okay?
Okay.
Anything else on the project?
Is there an example to this? like the other ones?
No, I didn't really do an example because you're just getting a set of 10 numbers. You're making your two graphs, you're finding your mean, median, mode, mid-range. You're finding your standard deviation and telling me what it means. I mean, I think we did an awful lot of examples in class where we found that type of information. It's just, applying it to your own data set.
Okay.
Okay.
So can you do like anything like with it? Like you could do like their like say you want to like do their age,
Yeah, you could do their
like,
age,
their height or weight or anything.
their height, their weight. If you're doing the baseball team, their batting averages. If you're doing the baseball team, how many bases they ran. If you're doing the hockey team, how many goals they scored as opposed to how many points they earned, as opposed to their, I guess there's something called a plus minus average. If you're doing, whatever floats your boat.
Yeah.
Okay, whatever interests you.
Yeah.
Okay. And if you aren't interested in any of the sports teams, you can gather your own information. All right.
Okay.
So that having been said, I don't think that that's too terrible a project. So now then going to review. I took the liberty of redoing that sheet with spaces in between to write on in class. I'm going to try to make these a little bit bigger. It should be the same information that I had put in Blackboard, just spaced differently. So the first one asks you to make a frequency distribution, and it's going to be a grouped frequency distribution. And so for this group frequency distribution, our data values are our quiz grades. And it's up to you. Do you guys want to make a tally or do you want to just count?
Tally, I think.
Okay, then let's make a tally. And then from our tally, let's find the frequency. And the first class is 5 to 9. So the next class would be 10 to 14. And our class widths are going to be 5. So the next class will be 15 to 19. Then 20 to 24. And yes, there is 125. So then we'll have 25 to 29. Now doing my tally, first one's a 20, second one is a 10. Then we've got a 9. Then we've got an 11. Then we've got 14. Then we've got a 25, an 18, 12, 14. You don't have to cross them out, but if I don't cross them out, I start going cross-eyed. 15, 22, 23, 10, 22, 25, 15, 23, 13, 15, 23, 8. Oh, and that's it. So my frequencies are 2, 8, 4, 7, 2. Easy enough.
Yeah.
Frequency distribution sounds much
It's okay.
better
I'm in
than it
class.
is. We're just making a table recording how many grades there were in each category. Everybody comfortable with that?
Yeah.
All right, great. Then if those are all right, next question, I've got grades, and I want to make a stem and leaf plot of the grades. with this, there are a couple things that I get nitpicky about with the stem and leaf plot. I'm going to go through and first make my sloppy copy. And as I look at this table, it looks like the lowest grades were in the 60s. And the highest grades were in the 90s. So I'm going to go through. First, I have an 85, then a 61, a 61, a 76, an 80, an 86, an 83, a 60, a 92, an 87, a 68, a 90, a 65, a 93, two 75s, a 71, a 76, a 63, an 88, and a 96. But that's my sloppy copy. My neat copy should have a title, test scores. On my neat copy, I need to put the leaves not in the order that they occurred, but in ascending order. So after 6, I have 0, 1, 1, 3, 5, 8. We've got to order those leaves. I have 1, 5, 6. Let me go through and do I need to mute everybody or are you guys okay? Then after the 80s, in order, I'd have 0, 3, 5, 6, 7, 8. And in the 90s, I'd have an order 0, 2, 3, 6. And then the other thing that I'd like to see is a key. And you can pull any of the numbers off there. I might say that 71 means the number 71.
Okay.
Does everybody remember how to make a stem and leaf diagram?
Yep.
Again, it's just kind of like the frequency distribution and a way of organizing the data values. Key's important. I promise you'll lose at least a point if you don't give me a key. Title's important. I promise you'll lose at least a point if you don't give me a title. If that's all right. I have here a list of class absences. I want a frequency distribution. From that, I'm going to make a histogram. Then I'm going to find the mean, median, mode, and mid-range. So for the frequency distribution, this one is not grouped. So I'm going to have absences. And then the frequency or the number of students. And the absences go from 1 to 11. And so let's see, I'm going to count. I have 1, 2, 3, 4, 5. Is everybody all right? 5 students with 1 absent. 2, I have 1, 2, 3, 4, 5 students with 2 absences. 3, 1, 2 students with 3 absences. 4, 2 students with 4 absences. 5, oh, there's 1. 1 student with 5 absences. 6. 1 student with 6 absences. Does anybody see any with 7 absences?
No.
No.
0 with 7. 8, there's 1,
2, 3.
3 with 8 absences. 9, there's 1, 2 with 9 absences. None with 10. And then 1, oh, I forgot I had 12 in there. Yikes. So my diagram's going to be a little cockeyed. I'm sorry. 2 with 11 and 1 with 12. And so that's my frequency distribution. Histogram. Need a title. Label, this would be the number of absences. This would be my frequency. Highest frequency is 5. And my absence will go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so above 1, centered at 1, we'll have a bar with a height of 5. Above 2, we'll have a bar with a height of 5. Above 3, we'll have a bar with a height of 2. Above 4, we'll have a bar with a height of 2. Above 5, we'll have a bar with a height of 1. Above 6, we'll have a bar with a height of 1. 7, we have a bar with a height of 0. 8, we have a bar with a height of 3. I'm sorry, my bars are really skinny. Hopefully your drawing will look a little bit prettier than mine. Above 9, we'll have a bar with a height of 2. 10 is a bar with a height of 0. 11, there is a bar with a height of 2. And 12, there is a bar with a height of 1. Now, in terms of measures of central tendency, I'm going to be a jerk and do the easiest first. Mode. Which one had the highest frequency? Both 1 and 2 had a frequency of 5.
Oh,
So the mode would be 1 and 2. Mid-range, we're taking the smallest number 1 plus the largest number 12 and dividing by 2 would be 6.5. Now for the median, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 values. So I'm going to look at the position of the median. Which would be 24 plus 1 over 2 would be 12.5. So it would be halfway between 12 and 13 score. Now, in order to get that, you can use your frequency column, or you can start just putting the data in order. Putting the data in order, I have 1, 2, 3, 4, 5 ones. I have 5 twos. 1, 2, 3, 4, 5 twos. I have 2 threes. That's my 12th number. I have 2 fours. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is everybody all right? Halfway between my 12th and 13 numbers. My median would be 3.5.
Yes.
And then for the mean, we can go ahead and just add up all the numbers and divide by 24. Or with the frequency distribution, sometimes it's easier to take the data value and multiply it by the frequency and add those. So 1 times 5 is 5, 2 times 5 is 10, 3 times 2, 4 times 2, 5 times 1, 6 times 1, 7 times 0, 8 times 3, 9 times 2, 10 times 0, 11 times 2, 12 times 1. And then if I add those up, just a little bit less addition, 5 plus 10 plus 6 plus 8 plus 5 plus 6 plus 0 plus 24 plus 18 plus 22 plus 12. So that adds up to 116 absences. And when I divide that by the 24 students, I get a mean of 4.8.
Can you just go back and show me how you got the mid range again? I missed that part. I was doing the Instagram stuff. I'm sorry.
Don't ever apologize.
No, I
Mid
couldn't hear you.
is always the highest value plus the lowest value divided by 2. And so the highest number was 12, the lowest number was 1. And so 13 divided by 2 is 6.5. Better?
Yep.
How's that question?
It sounded a lot harder than what it actually was. That's my personal opinion.
Yeah, it really, you're gonna have to draw a histogram, and then you're gonna have to find mean, median, mode, mid-range, and standard deviation also, which is what question 4 does. So there's a little bit of repetition between question 3 and 4 here. I don't think there's as much repetition on the actual test. And I have to apologize, this data is old. I can't remember which year the turkey trot it was from. Do any of you guys ever run the turkey trot?
Yes.
Yes?
Well, I walk it fast.
Okay, all right. I did it once because when my son went away to college, we signed him up, but he took the train back from Chicago and was late. So I went with his number, and I did much more walking than running in any way, shape, or form. But so here we've got data. And we've got a sample size of 10. Should we put the numbers in order, or should we just put them in? We'll just put them in. 24, 31, 19, 22, 21, 21, 20, 21, 23, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so when you add all those up, what do you get?
125.
125?
225, I believe.
Okay, 225. That sounds better. And so for the mean, what am I going to do with that 225?
Divide it by 10.
So it gives me the average age of those fast runners that finished early was 22.5. In order to find the median, what would you suggest I do?
Line all the numbers up and then pick out the middle values.
Line them up though in order, right? So the
Yes.
smallest is 19, then we have 20, then we have 3 21s.
Yep.
Then what do we have?
220. We have 122,
220,
223, then 24, and
31.
31.
So the middle of the list is Yep. between 21 and 22. So is everybody all right? The median would be 21 and a half. Halfway between.
Yeah.
What's the mode?
21.
21. There are more 21-year olders than anything else. What's the mid-range?
25.
21.5.
And where'd you get that?
It's right in the middle of.
No, it's 12.
I
Okay,
thought it was 25.
30,
Yeah.
31 minus 19.
mid-range, the middle of the range, the small, youngest is 19, the oldest is 31.
30.
And so that's 50
Okay.
divided by 2, or 25.
Okay.
All right.
Now, those of you who said 12, that's the range. The
Okay.
range is just the highest minus the lowest,
Okay.
which is 12. And does it make sense? Because it's a lot more work than any of those others. The standard deviation is going to have a slightly higher point value than the rest.
Yes.
Yes. For the standard deviation, we're going to take our mean, which is 22.5. And I'm getting lazy, so I'm going to stop writing it and subtract it from each of these. So 24 minus 22.5 gives me 1.5. And I'm going to square them as I work across because it's easier for me to square it while it's in my calculator. 1.5 squared is 2.25. Then let's see, 31 minus 22.5 is 8.5. Squared is 72.25. 19 minus 22.5 is negative 3.5. Squared is 12.25. This one is negative 0.5. Squared is 0.25. 21 minus 22.5 is negative 1.5. Squared is 2.25. Next one would also be negative 1.5. Squared is 2.25. Next one would be negative 2.5. Squared is 6.25. Then I have negative 1.5. Squared is 2.25. 23 minus 22.5 is 0.5. Squared is 0.25. And again, 0.5 squared is 0.25. Middle column should add up to 0. And then the squared column is, anybody want to do that adding for me, or are you guys going to make me do that adding?
100.5.
100.5?
That's what I got anyways.
Okay, somebody want to check, or did somebody else get the same results?
Let's see. That's mine. Yeah, I got 100.5 on mine.
The variance would be that 100.5 divided by number one less 9.
Okay. And that, I got 11.2.
Let's keep the 11.167, but now without
Okay.
taking the number out of the calculator for the standard deviation, we're going to take the square root of that.
Okay.
Why is that 6?
It's it should be 9. I have no idea why it's 6.
Oh, sorry.
A senior moment. And I'm getting 3.3. I was trying to just copy what was up above.
That's what I got too.
Wait, why you divided by 9?
3.4.
Because you always divide it by one less than the sample size. On the test, I'll have that formula in there. The formula says that the standard deviation is the sum of the values minus the mean squared divided by 1 less than the sample size. You're always going to divide it by 1 less than what you divide it by to get your mean. 1 less than the number of values. All right?
Can you not, I just want to copy down the formula really quick.
Okay. On the test, because if it were a actual pencil and paper test that you would be writing on, I'd have the table started for you and the formula written. On the Blackboard version of the test, I have an outline of the table, but you're not going to fill that in. Instead, you're going to do it pencil and paper because I don't want to make you have to type all of those values in. Unless you really want to. I find it easier to handwrite than type sometimes. This question, all right.
Sure.
Then next, we're saying that the mean height
Excuse me.
is 70 inches. Standard deviation is 4 inches. 2.5 standard deviations above the mean. Help, what do I do? The mean is 70. Above, would I add or subtract?
Add.
Add. 2.5 times my standard deviation is 4. And I think that gives me 80.
Yeah.
Next one, that's mean. If we want below, we'll subtract. 1.5 standard deviations means 1.5 times the 4, which I believe gives me 64.
Hmm.
Half a standard deviation above the mean. Above again means add. And this time I'm adding half of the standard deviation, which gives me 72. That one, all right.
Mhm.
1 second.
Next question, not yet.
Sure.
Next question, when I see that 68, 95, 99.7 rule, is everybody comfortable with drawing your bell curve? In the middle, what number should I label down below?
65.
Beautiful, because that's the mean. And then as I work my way out, how much should I add each time?
3.5.
For 5 inches.
Beautiful, so that'd be 68.5. Next one adding out would be 72. And next one adding out would be 75.5. And then in the other direction, I'll subtract. 65 minus 3.5 is 61.5. 61.5 minus 3.5 is 58. 58 minus 3.5 is 54.5. This first box I labeled with 68%. The second box I label with the 95%. And the outer box I label with the 99.7%. Oh, because I can, I'm gonna play with highlighters. Between 61.5 and 85.5, what percent would that be?
68.
68%. Whoops. That doesn't look good, 68%. Next one, between 65 and 72.
47.5.
How'd you get that? I like it.
I added 34 and 13.5 because that's the 65 to 68 and the 68 to 72.
Okay, all right. I also kind of look at it as half of the 98, 95 block.
Uh-huh.
So
My
that's
brain never works that easy.
divided by 2. Or if you got these divvied up, it also adds up to that same thing. And then last one asks for below 58. And you guys remember for below, we're going to take 58 as the boundary of 95. We want outside, so we're going to take 100 minus 95. And then we'll divide that by 2 to get 2.5%. That one all right.
Yeah.
I'm looking at this and I'm thinking I might have given you guys too much time for this.
No, I don't think so.
Okay. I'm giving you 75 minutes, I believe.
75 minutes. Okay.
Now, next question says, in a Gallup poll of 1,509 adults nationwide, as how much confidence Americans had in President Obama to do the right thing for the economy? Is it obvious that this question is like 8 years old? So, margin of error. 1 over the square root of the sample size times 100. What would my sample size be here?
1,509.
1509.
And so when you take 1 divided by the square root of 1509 and multiply it by 100, it would be better if I did this with my calculator than my phone, you think?
Huh.
Is anybody else getting to the nearest 10th 2.6%?
Yes.
Yes.
So now what do I do with that margin of error?
You add and subtract it to the percentage.
So 71 plus 2.6 is 73.6. And 71 minus 2.6 is 68.4. And once I add it and subtract it, how do I start my statement?
I am 95% confident.
95% confident that
That
Uh,
between
In 68.4 and 73.6% of Americans thought Obama had a great deal.
Where did you get 95% from?
the formula that we use is always for the 95% level of confidence. So we will always be 95% confident in this class.
Okay.
If you take statistics, you're going to find a slightly different formula and your level of confidence can change. But in contemporary math, the formula that we use will always give us that 95% level of confidence. And I'm going to put ... So, but the formula that we have is always at 95% level of confidence.
Uh-huh,
That one, all right.
I guess.
And then last question, change each into a Z-score and find the percentage of people that fit the description. For this one, on the test, I have a copy of that Z table inserted. I have to apologize. I forgot to insert it in this document.
Okay,
On the test, that Z table is inserted a couple of times. So below 42%, remember the Z-score is the value minus the mean divided by the standard deviation. So it would be 142 minus 121 divided by 15, which is 21 divided by 15, which is 7/5, which is 14/10, which would be 1.4.
Yep.
Yeah.
Is everybody all right for the percent below? We just take the table number.
Okay. That equals to 91.92.
Above 130, we need the Z-score for 130, which is 130 minus,
The 1.4, the percentile below is 91.92.
yeah, that's what somebody told me, so we got it.
I think you're writing 91.19.
Is that what you said?
No,
Oh, okay, I heard wrong.
91.92.
92, okay,
Yeah.
I apologize, I misheard. It's a good thing there's an eraser in here. So here, the next one would be 9/15, which is 0.6, I think.
Yes.
Yeah.
And so from the table for 0.60,
72.57.
72.57%. But since it's above, what should I do with that?
Check it.
Subtract it from 100, which gives me 7.43%.
wait, oh,
Yes.
Mhm.
Last one, because I'm worried about time, I'm going to change it just a little bit. Are you guys all right if I become lazy and change that 112 to 142?
Okay.
okay,
Okay, so for 142, we already know that it's at the 91.92 percentile. For 130, we already know from the table it's at the 72.57 percentile. So for between, we're just going to subtract those numbers. How's it look?
Good.
yes,
If your
okay.
table is close to, if your test is close to this document, how do you folks think you'll do?
Okay.
Okay. All right, there's one mild surprise question in there that asks you to use some data about yourself. So
What? Oh,
it'll be
God.
fun. It'll be fun. So if that's all right, then I'm going to stop sharing and say that test is in Blackboard. I do believe that it should be available later today. And I'll go through and change it. Right now I have it till the end of the 18th, but I'll change it to the end of the 19th.
Okay.
Okay.
Thank you.
All
Thank
right.
you.
Any questions? Oh, a
How
couple
many
of you
questions are there?
I'd like 8 or 9. It's
Oh.
close to this review sheet.
That's good. Thank
Okay. Who came in late?
me.
They have so many
Me
cards.
is who?
Hussein, sorry.
Hussein, I think I got you.
Oh, thank you.
Omaru, you came in late, right?
Yeah.
See ya.
Last name. I got you. Anybody else come in late? All right, then have a great day and we will.
Oh, I did. Kylie.
Kylie, I think I got you too. I think you were here actually on time.
Oh, okay. And Taylor Lockwood, she told me to tell you that her laptop wasn't working and it wouldn't let her join on her phone.
Okay, could you please make sure she gets what we did? Can you tell her, what we went over
Yeah.
and have her look at the video?
Yeah.
Okay. All right. Thank you.